friends, today let us work out some problems as the revision questions part 2. In part 1 we are dealing mainly with the Joule's law and power and other problems. In part 2, here we are discussing about resistors in parallel and series and the connected problems. This is the question. There are two resistors, 2 ohm resistance and 3 ohm resistance and 6 ohm resistance connected as given in the figure, and there is one voltmeter across 3 ohms and ammeter in the circuit. We have to answer the questions. First, find effective resistance of the circuit. What will be the ammeter reading? Then what will be the voltmeter reading? How much is the current through 2 ohm and 6 ohm resistors? The last, in which resistor heat generated will be more? Why? So this is the question. This question has some importance here. If you answer this question, you can answer all the questions in this section, that is of our resistors in series, parallel and effective resistance in both the cases, and what is happening in series connection and what is happening in parallel. All applications are there in this question. So this question is so designed. Once we analyze this question, I am sure you will be thorough with all the points and you will be getting a confidence to do all the problems from this side. Let us start with. Here, first we have to see the structure, the circuit diagram. Here there are two resistors, 2 ohms and 6 ohms. How are they connected? You can recollect it and tell. They are in parallel. Now, this 3 ohm is connected to this circuit after this side parallel connection. So this and the full 2 and 6 are in series, and it is connected through ammeter to a 9 volt battery or 9 volt cell. That is voltage of the circuit. Now we have to see first effective resistance of the circuit. Effective resistance of the circuit is called not only this. Here there are two parts actually. These 2 and 6 are in one way. They are in parallel. So there is one effective resistance. Then total effective resistance of the circuit. So for convenience, I replace these two as a single resistance, and this one is our 3 ohm resistor. So how many resistors are there now? This is the effective resistance of these two parallel connection. For convenience, I am calling it as RP, resistance, effective resistance of parallel connection. Then comes our 3 ohms, that is next resistor in series with the resistance. So first we calculate the effective resistance RP. We have studied if these two are the resistors in parallel, R is equal to R1 R2 by R1 plus R2. That is the equation for resistors in parallel. Now substitute the values, we will get the answer. 2 into 6 by 2 plus 6, that is 12 by 8, which is equal to 1.5 ohm. That is effective resistance. Convenience, we call it as RP. This is only for understanding what is that RP. There is no term in the textbook called RP. It's only R, effective resistance. Here we call it is for this combination RP. Now you can see this RP. Now we have got 1.5 ohm and this 3 ohm. They are in series. So we can do the final effective resistance of these two as they are in series. We know R is equal to R1 plus R2, which is here 1.5, and another is 3 ohms, that is 4.5 ohms. I think you got this idea clearly. This effective resistance, we have taken two stages. First the combination, then these two as they are in series. So effective resistance, here the question we have to write the answer. Effective resistance is 4.5 ohm. Okay, now goes to the next, ammeter reading. Actually ammeter reading is nothing but amperage of the circuit. That ammeter is used to measure the current. So indirectly they are asking what is that answer actually. Ammeter reading means ampere we have to calculate. That is current intensity of electric current. So this type of terminology we have to familiar with. Sometimes I will ask some reading of a meter. What is read by the meter? We have to think of. So it is current we are measuring by ammeter. So what is the current? Now we have to consider the resistance as a whole from here to here. Full resistance. That is our effective resistance, and 9 volt is the cell voltage. So we know I is equal to V by R, where V is the voltage line and R is the effective resistance. That is the full resistance, not this one or this one. Full, that is 4.5. What is a 9 by 4.5? We get 2 ampere. So this ammeter, if you connect here or here or here, not here and here, that you have to see. So this ammeter, wherever it is connected, then this combination we get 2 ampere reading. So ammeter reading, next question we are getting 2 ampere. That also over. Now comes voltmeter reading. Where is that voltmeter connected? Voltmeter is connected across 3 ohms. So 3 ohm is the resistance and here 9 volt is the voltage. And effective resistance we already calculated and current we already got. Using these all we can calculate the voltage across 3 ohms. That is the reading of voltmeter. How can we calculate voltage if current and resistance are there? These two are needed because this is a circuit. Once we have considered these two, it is a series connection. Wherever you measure, current is 2 ampere, no change, and resistance is 2 ohms. So what is volt? V is equal to, we know, IR. That is I is 2, R is 3, 6 volt. So that part also we have covered or we have done. Voltmeter reading, that is 6 volt. That is 6. Volt is the unit of volt. So 6 volt or reading is 6. You can write 6 volt, no problem. Now comes another question. Current through 2 ohms and 6 ohms. Then we have to think a little. Here 3 ohms we already got voltage of 6 volt. 9 volt is total voltage. We have studied in series voltage is split or divided. Here 9 volt is divided by this 3 ohm 6 volt. So the remaining is available between these terminals. If we connect here one voltmeter, this combination will give another voltage. What will be the voltage? Just think of here 9, here 6. Available voltage is 9 minus 6, 3 volt. So 3 volt here in between these two, 3 volt. And with this 3 volt, as it is a parallel connection, again recollect about parallel connection, voltage is the same for both the resistors. So there will be a current through this resistance and current through this resistance, and total current will be flowing through the circuit. So that current we have to separately calculate. Current through 2 ohms, this is resistance and this is the voltage. So what is current? I is equal to, this resistance value is there, voltage is here. So this current is I is equal to V by R, which is equal to V3 by R2, 1.5 ampere. Now what about current through 6 ohms? Same way, this is, if we call it as I1 we have calculated. Now this is I2. If I call this one as I2 is equal to this R2 ohms. This R1 we can consider. This R2 we can consider. V by R2. Here voltage is again 3 volt by 6. 3 by 6.5 ampere. Then you have to appreciate these values 1.5 and 0.5. Just add. we get the same amperage that we have got 2 ampere. So here we get 1.5 ampere and here we are getting 0.5 ampere. Together we will get 2 ampere. So it will split into I1 and I2, but it will be nothing but total current in the circuit 2 ampere. This type of points, once you get, you will be much happy to see all these things are there. Once we are getting all the values what we have studied in theory, it is coming in practical, and you have to enjoy that beauty of mathematics that we are doing here. Now comes, so in first part and this one second part, 2 ohms 1.5 and 6 ohms 0.5. Now comes, in which resistor more heat is generated. Actually it is not coming to this part that we already studied in last part. This is assignment for you. As I am telling, I am welcoming you for this video, today's video. Don't consider it as only a mere video. It is a class. So you must have a pen and paper with you, and you have to do this assignment, and you follow the class, then only you will be getting the benefit of the class. And I am sure that you will do this assignment sincerely so that you can get all the ideas connected to this. So I will give you the clue how you are doing. Heat generated, we have studied Joule's law, depends on so many factors. Current is there and resistance is there, voltage is there. There are so many equations connected to all this. Any you can use, because we have the here voltage here, current here, resistance here. So which one is easier for you? You can substitute and calculate all the values, and which one is greater, even with that calculation we will get now by this time. This is 6 volt and current is there 2 ampere and 3 ohms resistance, 6 volt, and this ampere will give you some clue. Anyway, I am not giving you the answer now. You can just find out the answer and answer this question: in which resistor, 2, 6 or 3, we are getting more heat energy. See, I give you one more request. I am telling you one more request. I am giving you this video, and you are watching the video, and you are free to comment on it. Commenting means if you have any doubt, if you want to get some clarification, you can, without any hesitation, you can ask in that comment part, "Sir, I didn't understand this one," or "little more clarification is needed." Sure, I will consider your comment and I will give you this clarification in the following videos. So please see that you are subscribing and you are just what that comment part, you just fill that part, and notification also if you just activate, you will get the video the very first day itself, immediately when it is released. So please see these points too.